Good morning. In the chemical reactions of ether, when it's come to its mechanism, in step 1, the protonation of the ether takes place. When the tertiary butyl methyl ether is treated with hydrogen iodide, we can get protonated ether. And in the step 2 and 3 in the SN1 reaction, protonated ether yields the tertiary butyl cation, which then combines with the nucleophile I negative to form tertiary butyl iodide. And when an aryl ether is heated with concentrated HI or HBr, the cleavage of the CO bond occurs with the formation of phenol and alkyl halide. For example, when anisole is heated with concentrated HI, the cleavage of the carbon-oxygen bond occurs with the formation of phenol and iodomethane. This is because in the methyl phenol oxidation formed by the protonation of ether in the first step, the OCH3 bond is weaker than the OC6H5 bond because first the carbon of the phenyl group is sp2 hybridized and hence more electronegative than the sp3 hybridized carbon of the methyl group. And second, there is partial double bond character for the OC6H5 bond due to the resonance. And for the last, due to the steric effect, the attack of the iodide ion on the smaller methyl group is favored than that of the larger phenyl group. And in this case, phenol does not react further to give iodobenzene because the sp2 hybridized carbon of phenol cannot undergo nucleophilic substitution reaction needed for conversion to the iodide. If we consider further cases, the oxidation by air and light. Organic chemists often say that ethers are the least reactive to of the functional groups. And when exposed to air and light for a long time, ethers may get oxidized to form hydroperoxide and peroxides. These peroxides may violently explode at high temperature. So care must be taken when ethers, especially old samples, are distilled as they may contain peroxides. The distillation may be done after treating with FeSO4 or an aqueous solution of Ki, which will reduce the ether peroxide. In the halogenation, ether reacts with Cl2 or Br2 to give halogenated ethers. Like ethoxyethane, when reacted with chlorine, we can get chlorinated ethers. And when we consider electrophilic substitution in aromatic ethers, the alkoxy group is orthopara directing and activities the aromatic ring towards electrophilic substitution in the same way as in the phenol. In halogenation, phenyl alkyl ether undergo usual halogenation in the benzene ring. For example, anisole undergo bromination with bromine in acetic acid even in the absence of iron bromide catalyst. We can get in this reaction para-bromoanisole and ortho-bromoanisole. Here, para-bromoanisole is the major product and ortho-bromoanisole is the minor product. And the para-isomer is obtained in the 90% of yield. In its Friedel-Crafts reaction, anisole undergoes Friedel-Crafts reaction. That is, the alkyl and acyl group are introduced at ortho and para positions by reactions with alkyl halide and acyl halide in the presence of anhydrous aluminum chloride. Here, anisole is treated with methyl chloride in the presence of anhydrous AlCl3. We get 4-methoxytoluene as major product and 2-methoxytoluene as minor product. And when anisole is treated with ethanol chloride or acetyl chloride in the presence of anhydrous AlCl3, we get 4-methoxyacetophenone as major product and 2-methoxyacetophenone as minor product. And in the nitration, anisole reacts with a mixture of concentrated nitric and sulfuric acid to yield a mixture of ortho and para nitroanisoles. Here, anisole reacts with nitric acid or sulfuric acid. We can get 4-nitroanisole as major product or 2-nitronisole as minor product. Thank you.